Welcome back to our channel. Today, we're diving into one of the most mind-bending questions of all time. Is the universe a living being? Could it be that everything we see, from galaxies to stars to distant planets, forms part of a single, colossal entity? And if that's true, what role do we play within it? Recent discoveries from the James Webb Space Telescope have left scientists amazed, and some say even a little shaken. They're seeing things that could suggest a new way of thinking about the universe, and maybe even our place within it. Get ready as we explore this incredible concept and reveal what the Webb telescope just captured that's raising these extraordinary questions. Stick around until the end, because what you're about to hear might just change the way you see everything. Scientists are buzzing with excitement over groundbreaking new findings from the James Webb Space Telescope. Recently, this telescope observed something astonishing, something that doesn't seem to align with the physical laws we thought we understood. This surprising discovery has led some scientists to propose a mind-bending idea. What if the universe itself behaves like a living system, one that evolves over time? I don't subscribe to any religion, and in that sense, I consider myself an atheist. But even from this perspective, it feels as though there might be something happening on a cosmic level that could resonate with a spiritual viewpoint. When we think of the universe, we usually picture a massive expanse of matter, all governed by physical laws that dictate everything from the movement of stars and galaxies to the behavior of tiny particles. For centuries, scientists have trusted that by uncovering these laws, we could one day fully understand how the universe operates. And indeed, the laws of physics have done a remarkable job explaining phenomena, from the orbits of planets to the interactions of subatomic particles. But here's the twist. When we try to look back to the very origins of the universe, these well-established physical laws start to fall apart. The physics we rely on to explain the world around us begins to break down entirely. Today's scientific understanding can't fully explain the mysterious conditions of the early universe. But recent discoveries by the James Webb Space Telescope are beginning to reveal a hidden complexity. As Webb looks further back in time, it uncovers surprising clues that challenge our current theories. Instead of falling neatly into our models, the early universe seems to defy them. For example, scientists expected to find small, developing galaxies in the early universe. But Webb has spotted massive galaxies existing just a few 100 million years after the Big Bang, much earlier than previously thought possible. Even more perplexing, Webb has detected a supermassive black hole that formed only 1.5 billion years after the Big Bang. What's astonishing about this black hole is that it's consuming matter at 40 times its theoretical limit, growing at a rate that current cosmic models can't explain. These discoveries suggest that the early universe, just a few 100 million years after the Big Bang, was radically different from the universe we know today. Some scientists now wonder if the laws of physics might have operated differently back then, allowing phenomena that we no longer observe in our current universe. And it's not just about finding unexpected galaxies or black holes. These revelations are reshaping our entire understanding of how the cosmos evolved. The James Webb Space Telescope is shaking up our most basic ideas about the universe. For example, Webb's observations have detected signs of non-uniform expansion of space, suggesting that we're still missing something critical about the universe's nature. These findings are prompting scientists to rethink everything they thought they understood. Adding more fuel to this debate, Webb's latest discoveries have revealed intriguing clues about the universe's evolution. New studies now suggest that our universe may be evolving much like a living organism. This idea has ignited a major debate in the field of astronomy, with some scientists now exploring the concept of a living universe to explain some of the cosmos's greatest mysteries. Lee Moulin, a physics professor at the Pennsylvania State University Center for Gravitational Physics and Geometry, is at the forefront of this bold theory. Moulin and his team are delving into the possibility that the universe might operate more like a living system than we ever imagined. According to researchers, the universe we observe today appears to be in a rare and unexpected state, one that challenges conventional ideas about how it formed and what might lie ahead. If the universe simply emerged from the Big Bang, we might expect a straightforward path of development. But surprisingly, there's an ancient idea shared by both philosophy and science that the universe itself could be something more, a sentient or self-aware system. New observations from the James Webb Space Telescope are lending weight to this theory, revealing a universe that seems to evolve and change almost like a living organism. Over the years, some experiments have hinted that the universe might actually behave in ways that mirror living systems. One fascinating study from 2020 by astrophysicist Franco Vazza and neuroscientist Alberto Folletti explored remarkable similarities between the large-scale structure of the universe, known as the cosmic web, and the human brain. By examining the network of neurons in the brain and comparing it to the network of galaxies in the observable universe, they discovered unexpected parallels. Both systems showed similar levels of complexity and density in their structures. For example, while the human brain contains around 86 billion neurons, the observable universe holds roughly 100 billion galaxies, each connected through vast networks of filaments and nodes. These similarities raise intriguing questions. Could the universe be alive in ways we're only beginning to grasp? Such ideas are pushing the boundaries of how we understand life, consciousness, and the very nature of the cosmos itself. Both the human brain and the universe appear to organize their energy and matter in similar ways. In both systems, about 25 to 30% of their structures are active components, neurons in the brain, galaxies in the universe, while the rest consists of inactive material like neuron connections and dark matter webs. This discovery has sparked speculation that the universe might function like a giant brain, perhaps even processing information. While still a highly theoretical idea, it raises an intriguing question. Could the universe itself be alive? Adding to this notion, another recent experiment suggests that the universe might actually observe everything within it, almost like a living entity. Theoretical physicist Goddamn Says Chandran of Princeton University, along with physicists Danny Danielson and Robert Wald from the University of Chicago, conducted a thought-provoking quantum experiment near a black hole. Their findings suggested that a black hole could act as a kind of cosmic observer. To explore this, the team envisioned a scenario with an observer, named Alice, performing the famous double-slit experiment while orbiting a black hole. As many of you know, in the double-slit experiment, scientists send particles through two slits to observe whether they behave as particles or waves. Imagine an electron or photon being sent toward a pair of slits in a solid barrier. If no one observes its path, an interference pattern characteristic of waves appears on a screen beyond the slits, as if the particle had passed through both slits simultaneously. But if an observer or device measures which slit the particle passes through, it behaves like a particle, traveling through one slit or the other. This measurement causes the particle's quantum state to collapse, losing its ghostly in two places at once quality. Now, here's the twist. Scientists added a new element to the experiment, another observer named Bob, who is positioned just inside the event horizon of a black hole. The event horizon is essentially the point of no return, beyond which nothing, not even light, can escape the black hole's intense gravitational pull. Although Bob is trapped, he can still make observations. When Bob, inside the black hole, observes which slit Alice's particle passed through, the particle's quantum state collapses instantly. In theory, Alice would immediately realize that Bob is observing, disrupting her experiment. But this creates a paradox. According to the laws of physics, nothing that happens within a black hole should affect anything outside of it. Bob, by all accounts, shouldn't be able to communicate with Alice from within the event horizon. And yet, through this observation, it seems that his actions inside the black hole do indeed have an effect outside, challenging our current understanding of reality itself. Alice realizes that Bob must have observed the electron's path, yet this raises a fundamental question. How could she know this? Black holes are like one-way streets. Nothing from within a black hole should impact experiments outside it. And yet, in our scenario, Bob's actions inside the black hole seem to interfere with Alice's experiment outside. To resolve this paradox, the research team proposed a daring solution. They suggested that the black hole itself forces Alice's particle to collapse into a defined state, with or without Bob's involvement. Theoretical physicist Sis Chandran explained that the event horizon of the black hole knows which path the particle took, making it the true disruptor of Alice's experiment, not Bob. With this twist, the paradox is resolved. Scientists believe there is something uniquely insidious about these horizon effects. Normally, physicists can keep particles in isolated superposition states by carefully shielding their experiments from outside interference. For example, creating a vacuum around an experiment can prevent particles from collapsing by eliminating interference from gas molecules. But with gravity, there's no shielding. Its effects reach across vast distances. Thus, experiments near black holes are always subject to gravity's influence, no matter how isolated they seem to be. The idea that the universe could be alive is more than just science fiction. This concept has roots in ancient philosophy, with ideas suggesting that the cosmos might operate as one giant, interconnected organism. Modern science has typically viewed space as a vast, mostly empty region dotted with galaxies and planets. But what if the universe is more than that? What if it has some form of consciousness or even a purpose? Imagine the universe as a massive, interconnected system where every particle, star, and galaxy is part of a greater, self-regulating whole. This is similar to how a human body functions, with organs and cells all working together to maintain life. For the first time, the James Webb Telescope is giving scientists glimpses of patterns, connections, and behaviors in space that seem eerily organic. It's almost as if the universe has a structure or network that mirrors life itself. But what could this mean for science and philosophy? Now, here's where things get even more intriguing. The James Webb Telescope, launched in December 2021, is equipped with the most advanced imaging technology we've ever sent into space. Recently, it captured something truly unexpected: structures and formations on a massive scale that don't quite fit our current understanding. These formations resemble filaments that stretch across galaxies and appear to be connected like veins in a body. Scientists have named this the cosmic web, and it's a network of dark matter and galaxies that may link the entire universe. This discovery is pushing researchers to ask if these connections serve a purpose beyond gravity, or if they have a role in keeping the universe alive in some sense. While it's still speculation, the Webb's images are stunning and suggest that these cosmic connections might be more than just random. One theory that adds an interesting angle to this mystery is the Gaia hypothesis. Originally applied to Earth's biosphere, this theory suggests that planets, including Earth, act almost like a single organism, self-regulating to support life. But some scientists are now expanding this hypothesis to a cosmic level, suggesting the entire universe could have similar self-regulating properties. If the universe does indeed have such properties, could it mean there's a kind of cosmic consciousness? While it sounds far-fetched, researchers argue that if life evolved out of this interconnected universe, there could be something intentional, even if it's only a faint awareness. The Gaia hypothesis on a universal scale is still highly debated, but the James Webb Telescope's findings are giving scientists reason to revisit this bold idea. Let's dive deeper into the science behind this idea. Quantum mechanics, a field that studies the smallest particles, has given rise to strange phenomena like entanglement, where particles remain connected regardless of distance. If particles can communicate in ways we don't fully understand, could this imply that the universe itself is communicating on some level? Some physicists speculate that if these particles behave in aware ways at small scales, then on larger scales, this interconnectedness might contribute to a form of consciousness. The James Webb Telescope's ability to detect these connections on an intergalactic scale is opening the door to rethinking the universe. It's a controversial idea, But could quantum mechanics reveal that the universe is more interconnected and alive than we previously thought? The idea of the universe as a living being isn't just a mind-bending concept, it could have significant implications for humanity. If scientists confirm that the universe functions like a single organism, it could shift how we see ourselves and our relationship with space. Rather than just inhabitants of a vast, empty universe, we might be participants in a living, breathing entity. This could change how we think about environmental conservation, space exploration, and even artificial intelligence. It raises questions about how humanity should interact with the cosmos and what responsibilities we might have as part of a living universe. The James Webb Telescope's discoveries are leading us toward a new era of science, where concepts that once seemed impossible are being explored seriously. If the universe is indeed a living entity, it might self-regulate much like the Earth does. On Earth, our atmosphere, oceans, and ecosystems work in harmony, adjusting to changes in ways that maintain balance. Similarly, the universe's cosmic web, the network of dark matter and galaxies, might be maintaining cosmic stability. Some scientists speculate that certain events, like supernovas and black hole mergers, aren't just random, but could be part of a larger cosmic balance, ensuring that energy is redistributed and that galaxies stay organized. Dark matter and dark energy make up roughly 95% of the universe, yet we know very little about them. Could they be part of this hypothetical life force of the universe? Some researchers theorize that dark matter, which forms the cosmic web, could act like the universe's muscles, holding galaxies together, while dark energy might serve as its breath, expanding and contracting the cosmic structure. These forces in maintaining balance. If the cosmic web connects galaxies, it might serve a similar role, transferring information, or at least energy, across vast distances. This network could play a crucial role in how galaxies and other cosmic entities interact, influencing each other in unseen ways. Black holes have often been considered destructive forces, but recent research suggests they might also serve as cosmic recycling centers. They consume matter, compress it, and potentially release energy and particles in forms we don't fully understand. If the universe is alive, black holes could be akin to digestive systems, breaking down waste and redistributing energy across space. This process could be essential to the universe's metabolism, keeping the cosmic ecosystem balanced. Life on Earth exhibits symmetry and repeating patterns, from the shapes of leaves to the structures of cells. In the universe, we see similar patterns, such as the spiral structure of galaxies and the regular distribution of galaxies in the cosmic web. This symmetry isn't random. It could hint at an underlying order or design. The James Webb Telescope is helping scientists detect these patterns more clearly, and they're wondering if these cosmic structures could be signs of a living, organized universe. Supernova explosions are some of the most energetic events in the universe, scattering heavy elements essential for life as we know it. They help to spread materials like carbon and oxygen across space, which form the building blocks of planets and eventually life itself. If the universe is a living entity, these supernovas might serve a critical function, similar to the immune system in a body, spreading elements that heal or build the cosmic structure, enabling growth. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blesovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.